Hello everyone, in this video we'll be solving problem 1984, minimum difference between highest and lowest k scores. In the problem statement, we are given a zero indexed array nums where nums of I represents the ith student score. We need to pick the score of any k students in the array such that the difference between the highest and the lowest is the minimum. For instance, in example number 2, we have 9, 4, 1 and 7 as the input and k is given as 2. Between all possible combinations of size k, that is 2, the minimum difference is between 9 and 7, hence the output is 2. As marked by LeetCode, it is a very easy problem once we understand how we can solve it efficiently. So let's switch to whiteboard and discuss how we can solve it. Before we talk about an efficient solution, let's start by addressing it using brute force. In the brute force approach, as we are looking for the minimum difference, we try to build all possible combinations of size 3, identify the highest and the lowest with each pair, and calculate if it is the minimum. We'll maintain a global variable minimum difference which will hold the minimum difference that we calculated over all the pairs. This recursive iteration will be repeated for all possible pairs. For example, we'll start with 3, 11, 12, then 3, 11, 4, and so on. After exhausting all options or pairs starting with 3, we'll increment the pointer to start the next batch with 11 as the first point. As you can imagine, the overall time complexity of this solution will grow exponentially with higher values of k. Now that we understand the challenge with brute force approach, let's discuss an optimized approach. As we're trying to identify the minimum difference between a pair in the given array, the first step should be to sort the input array. In a sorted array, the lowest element are to the left while the highest element are to the right. Now if we want to know what is the minimum difference between the highest and the lowest, we can easily use two pointers, first pointing at the leftmost element and the second pointer pointing at the rightmost element, take the value and calculate the difference. As we need to work with the batches of size k, we need to keep on shifting towards the right as we increment the pointers. In other words, we are using the sliding window algorithm where we'll shift the pointers after calculating the difference between the highest and the lowest within that k range. For a given batch of size k, the first element is always going to be the lowest and the last element is always going to be highest because the input array is already sorted. So we don't have to worry about the elements in the center and only work with the corners. Let's do a quick dry run with this example to get a better idea. Here's the sorted version of the original input. With k is equal to 3, there are a total of 3 batches in the given input. Starting with the first batch 1, 3 and 4, 1 is the lowest as it is to the left and 4 is the highest in that batch. So the difference between the two is 3, which is the smallest so far. So we'll save that value in the minimum difference global variable. As you must have noticed, we are using a two pointers approach where the first pointer is pointing at the lowest element in the batch while the second pointer is pointing at the highest element. Moving on to the next batch, which is 3, 4 and 11. Lowest is 3, highest is 11, the difference is 8, which is greater than the minimum difference, so the value will not be overridden. Similarly, in the last batch, we have 4, 11 and 12. The difference between highest and lowest is 8, which is greater than the minimum difference, so no changes to minimum difference. As we have iterated through all possible pairs, we'll return the minimum difference as the output. The time complexity of this solution is O of n log n, as we are sorting the input array into ascending order before processing the batches, while the space complexity is O of 1, as we are doing in-place sorting and not using any additional memory. The only memory we are using is to store the minimum difference. I hope the explanation was helpful. Let's walk through its Python implementation. In this Python implementation, I start by adding a validation to make sure that the value of k is always greater than 1. If not, then we can't build any pairs to calculate the difference between the highest and the lowest, so in that case I am returning 0. Next step is to sort the input array in ascending order. Post sorting, the next step is to start a sliding window algorithm using a for loop where the first pointer I will be pointing at the first element of the k batch. Inside the for loop, I am calculating the difference between the first element that I is pointing and the last element that is pointed by I plus k minus 1, and if the difference is less than the minimum difference, the value will be saved back into the minimum difference variable. This code when submitted on LeetCode beats 100% of the submissions in terms of runtime and 13% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.